Hello, everyone, and thank you for joining us. We have a very interesting webinar planned, Fighting Financial Crimes, a deep dive with graph and machine learning. We know you're very busy, and we appreciate you taking time out of your day to join us. Next slide. I'm delighted to introduce today's speakers. We're joined by Graham Gansley, Head of Data Science at Expero, and also by Scott Heath, Head of Fraud, Graph and Analytics at Expero. Next slide. And with this, I'll pass things over to Scott to walk us through the agenda.
Actually, it's me, it's Graham. Hey everybody, I'm Graham. I will take you through a tour here today of some material and some resources on the use of graph and machine learning methodologies to increase the accuracy and the domain specificity of financial crimes-based systems. As we dig in today, just want to remind you, there's lots of links on both Expero's and TigerGraph's website about this. And if you want to see anything deeper, we have webinars, we have demos and case studies, blogs. They're all on the site. Encourage you to go check that stuff out. So let me kick it off with a motivation. Why do we care about this stuff? Well, as we've seen, the United Nations seems to think that this is a really big problem. And as practitioners, of course, we know that this truly is a huge problem. When we look market-wide, however, the setting is in the tens of billions of dollars money lost to from various financial institutions. And there is a common set of mechanisms by which fraudsters are able to steal this money. We're going to be talking today in the context of any money laundering based methods. Although as I go through this stuff, you'll hear me mention a couple of different types of fraud because the systems and the methods I'll talk about today apply not only to AML, but to other fraud settings as well. So let's look into the numbers a little bit more here. We are, as we just mentioned, UN says tens of billions of dollars, but if we look across global marketplaces, what we see is that this problem is in the money laundering space is hundreds of billions of dollars to trillions of dollars. That's huge. I mean, it is on the order of the GDP of some countries, right? And we can see how dramatically this affects the companies and the financial institutions that are involved. Speaking of which, they aren't all banks, right? I mean, anybody who's in the financial exchange business, and we have a few listed here, are affected by this behavior because fraudsters are smart, right? They don't want to continue the same attack vector all the time. I want to mention here that the connectedness and the connected behavior of fraudsters and non-fraudsters alike, that's important. We'll get to that later. Is necessary in understanding how to score transactions, risk-based scenarios in rings of entities, all that stuff, all those scoring mechanisms are heavily augmented by using that connectedness in those networks. It is no longer effective just to know your customer, right? I mean, part of what we're going to be talking about today is extending that KYC to KYCC, know your customer's customer. And the reason for that, of course, is because you want to have a complete picture of what's going on inside of those financial transactions and across domains so that you can trace money and trace the behavior of the customer's customer to understand why, not just when and how, but why those transactions are going on, to understand if they're fraudulent or not. So what is this going to look like in 2021 and in 2022? Our 18-month outlook on the space is that we will be using more and more graph plus machine learning based methods. And here is how they are implemented. What we saw in years past is this data cliff category, where we have data aggregation and visibility into those into those data. And that's really important. Of course, that's the foundation for doing any of this type of fraud prevention work. The next category here is using analytics to assist the decision-making processes of fraud investigators, analysts, fraud reviewers, these types of people. That is the realm of BI, business intelligence tools. That is the use of this data, especially structured data, to help make those decisions. But where we want to head, and what we're going to talk about today, is that third category in the yellow box. And that is the realm of augmentation and the automation of decision-making processes. So we will tell you today about how to use particular technologies like graph and machine learning to sort of upgrade your workflows from using a human interpreter to make the decisions to augmenting that interpreter's decisions using technology, and then in a fully iterative loop, using the information about the decision they eventually did land on to improve the systems themselves, and thus building what we call a data product, which is continuously adaptive. And that's what we're showing on the next slide. We want this continuous adaptation in our systems because if we have such a mechanism, it enables the system to learn from that rich domain context that I just mentioned. The system is no longer what we've seen in the past, these sort of individual data science projects or projects from your quants, for instance. It is a full product with feedback collection mechanisms, with monitoring, with adaptive maintenance in order to ingest the information that a user, that a domain expert user, like a level 1 fraud analyst, uses day to day in new unseen settings to be able to increase the power in every operational condition of your business. So what does the system look like? Well, we have a picture here of our logical flow of such a system. This is just a really high snapshot, of course. There are a couple of technologies mentioned here, but we'll get into the specifics in a few slides. This is, and over the section here that I'm going to go through, we're going to step through this from left to right on this diagram so that we can check out every individual piece. So left to right, we have information flowing into the system from your data sources. We then ingest that information into a common structure or common logical format that allows you then to understand where the entities in that data structure are the same. For instance, if you work inside of a large financial institution that has many systems of record, it is almost inevitable that you will have conflicting records that need to be resolved. The next piece, and this is where the meat of the analysis comes in, where the real value lies, is using, as I mentioned in the previous slides, new modern methodologies of analytics, including data science, machine learning, and graph, to be able to increase the accuracy of those analytics, to be able to more accurately detect behavior, fraudulent behavior, any money laundering schemes, those types of analyses. And then on the furthest right-hand side of the slide there, of course, we need to deliver this somehow to our users, who could be a fraud investigator in this case. And we do that through the use of sophisticated user interfaces, which again, also ingest feedback from the usage of those systems to upgrade this whole system left to right. So let's dig in. Let's check out the first part here, where we're looking into getting data into a system. There are many ways to do it. There are many different systems of record, as I just mentioned. But what we've seen across the industry, especially over the past year or two, is many financial institutions moving into a setting where they're using this FIBO, or financial industry business ontology. This is a common framework for storing data in a format that allows communication about the same types of financial records across institutions. So if you want to purchase a product that gives you, I don't know, let's say social information about your customers, if that organization uses this ontology, you're then able to communicate directly with the data systems you have in place. If you want to communicate across financial institutions, you will find increasingly that these institutions, including possibly your own, are using this ontology or derivative of this ontology to be able to structure the information in a meaningful and rich way. It's huge though. So what we're going to do in this type of analysis is we're going to extract pieces of this ontology because there's a lot of stuff in here that we don't need. And the next slide shows a couple different entities that we'll be talking about today. Those entities include accounts and corporations. And let's just pop over to the next slide quickly here, please, where we are looking at corporations, we're looking at accounts and transactions, we're looking at physical characteristics like addresses. And of course, what we see in this extraction, this FIBO supported ontology, is a relationship between all of those various entities in their sort of physical manifestation, right? Like a person can make a transaction with a company or with another person. There are both corporate and governmental regulatory authorities, which maintain lists of blacklisted companies, whitelisted companies, these types of things, so various levels of trust in these organizations, and all of the demographics that we just talked about. So this is the structure that we'll be talking about through this webinar. And the sort of beauty of using a graph database to house this information is that although the piece we're looking at here is quite small, of course, you are able to directly add to this schema any other information that's important to your business across business units, product lines, anything like that, as we just showed with that FIBO ontology. Okay, so once we have the information in there, as I mentioned before, we have to do some type of cleanup. And one of the things that we find most important, of course, is the ability to understand not only the entities that exist in the raw data, but also who those people or who those companies actually are in the real world. This is the machine learning half of the two-part machine learning graph-based resolution method that allows you to really accurately, I would actually say more accurately than has ever been useful in history of computing, to resolve the raw data into its true components. And although we're looking here at a very familiar type of similarity metric, I've just mentioned Hamming distance here as part of this algorithm. What we do that's new in the machine learning space is we actually allow the algorithm to tell us which things are most important in the data about why it thinks two records or n number of records are the same person or same company. So a bit of a mind shift there. In the past, of course, what we've done is we've built rules that say, hey, because of these two things, these two properties, we're fairly confident that those two companies, for instance, are the same company. Now, in the modern world, in this sort of probabilistic world, we say, well, actually, we want you to tell us, algorithm, what's important in the data to know how to resolve these entities. And the second piece of this is using the graph-based methods. Here we have a cartoon of the use of a graph-based mechanism to canonicalize data records inside of a graph database. So what we're doing here is we're using some matching criterion inside of the graph, where we see on the right-hand side those same as edges. And the way that those edges are built is by using a probabilistic weighting, as we saw in the last slide. But the beauty of doing this machine learning based method in the graph is that after we're done, we're then able to query over those same as edges and filter based on weights inside of that graph. And that gives us an even more crystal clear picture of which entities are the same, which companies are the same, which people are the same, and where they match. This is also really important, where they match against those known white and black lists based on various lists that we'll talk about later on. Okay, let's step forward a little bit and talk now about what we do once we have the data in, we've gotten some cleanup done. What are we going to do here? What type of mechanisms are we going to use to actually detect fraudulent behavior, potentially fraudulent behavior? And then in a few slides, we'll talk about the prevention of such behavior as well. This is the same schema I showed you before. This is just a little extract that relates to companies, persons, accounts, transactions. And what I'm showing here is not only the resolution, but the piece I mentioned on the last slide about the actual entity matching. So let's imagine that you are talking to the US Treasury and they say, hey, we have this list of sanctioned bad guys across the world. And this is not a hypothetical, this is an actual list that you can go download today. You can use this structure in this schema to do a much more accurate job matching the occurrences that you have in your business, who's transacting money on your system today, to that known blacklist. Equivalently, there are many whitelists, and indeed, if you want to get into the specifics, you can actually start to build your own gray lists out of this information. Suffice it to say, of course, that when you have this fully connected data set, you're no longer just matching based on, let's say, if name of company that we have in our system matches name of company on blacklist, then it's a bad transaction. This is a much richer representation of that information. Once we have that information, we are interested in doing the actual fraud detection work. And there are many ways of doing that. And on the next slide, I'm showing a bunch of different types of algorithms that are used in the process. On the left-hand side, we have graph-based algorithms. On the right-hand side, we have machine learning-based algorithms. All of these algorithms are important, and many of them are used in simultaneity when you're doing these types of detection and prevention methods. On the left, again, the graph algorithms can feed those machine learning algorithms information, and vice versa, later down the process, the machine learning algorithms will actually inject information back into the graph so that those graph-based algorithms and the analysts who are looking at the data that's in the graph have, again, a richer contextual representation of the companies and entities inside of that database, and will have not only recommendations about which behaviors appear fraudulent, but also about the confidence of the algorithm in making that decision. And as we'll talk about at the very end, the explanatory reasoning for why the algorithm made that decision. So let's look now at the next stage in this process. And that, of course, is the real meat and potatoes, this sort of detection methods as they actually operate inside of the system. This is a high-level look before we dive into a concrete implementation about how you operate these types of algorithms. You extract pieces of your graph and collapse them into a common machine learning framework, and then output the scores from that machine learning framework back into the graph, as I just mentioned, which feeds the UI and showcases those recommendations to the users. Okay, so let's look here at a couple of different graph-based algorithms in a little bit more detail that help us do this detection work. On the next slide, we have a list of those algorithms. So these are things like the actual paths inside of the graph. So that is, where's money flowing? There are neighborhood algorithms, this clustering notion, where you're actually segmenting out the behaviors inside of your known user base into their common behavior patterns. Similarities between individual records, like individual companies or groups of people or companies. And then doing this sort of categorization, the sort of classification of which things are fraudulent behavior, which things are normal. And then, of course, all of the intricate methodologies that inject information across known paths inside of the network. And those are really important to power the next piece of analysis, which we're showing on the next slide. This is a super detailed slide. We don't have to go through everything here, but this is an actual TensorFlow implementation of a fraud detection system. On the left-hand side, you see an extracted subgraph fed in the middle, fed into the TensorFlow neural network scoring framework, and then the output over time, by the way, as the potential for fraud on this ring of entities exists. Another way, and let's step back up to a high level here, of performing fraud-based recommendations is to do some type of unsupervised learning. So that is, hey, algorithm, go dig through the data and you tell me what you find. Tell me what types of systems or networks of companies and people you see in my data. Those things are teased out here in those clusters or neighborhoods are teased out here in cartoon form. But actually on the next slide, we have a real picture of this. Now, I've obfuscated the names of the companies here so that, just to protect customer data. But what you can see is the colors of these nodes are labeled by their cluster that we used on the last slide to detect those, whatever cluster these entities exist in, these companies exist in. And the question very simply is, once you have these sort of similar communities, these neighborhoods, what is the average risk level? And so if we step up to a more realistic data size, as we're doing on the next slide here, we see what this looks like across a larger graph database. And so on the left, we just have an unclustered blob of nodes and edges. But after clustering, we see common behavior patterns emerging. And we're able to use that neural network we showed before to actually do risk scoring, confidence of fraudulent behavior scoring on each one of these communities, which will allow investigators to dig in. Now, we can also show this at the transaction level, which we show on the next slide here. And that has a, one of these individuals nodes popped open with their individual fraudulent transactions suspected. As I mentioned, this is a transactional setting more than it is an AML setting, but the exact same types of analyses are applicable here. So just showing this here to showcase that these methods enable you to detect multiple types of fraud with the same system. So I think that's critically important. All right, let me show you the whole logical infrastructure here. What we're doing at the top of the slide is we're ingesting a bunch of different data sources. These are internal and external data sources, for instance, from various data providers in the fraud detection space, like Actimize or CyberSource or whoever. Ingesting the information from known blacklists. As I mentioned before, we have OpenCorporates, and we have, down here we have US Treasury lists, FinCEN lists. And then on the left there, we have all of the transactional record information that would come from inside of your organization. In the middle of the slide, what we have are the actual scoring mechanism, various scoring mechanisms, plural actually, that allow you to integrate logical business rules, graph-based detection methods, any type of fraud scoring you already have in-house. That's where we integrate that there in the middle and come up with a composite score. And then on the bottom, what we're seeing, and I'll show this in the UI here, because I know that this is a little bit high level right now, is to allow the user to share their feedback with the system. This is what it looks like. We have here a set of UI screens that showcase on this screen the user, this decision-making rationale from the algorithm as that whoever level 1 fraud analyst comes in and says, hey, I'm not sure that this recommendation is correct, algorithm. Why don't you tell me why you made the decision? And we can see here that it's actually this particular transaction is in a neighborhood of transactions that are known to be fraudulent. And so digging deeper into that, on the next slide, we show the actual connections in that community here in this grid-based view. And as this fraud analyst says, okay, actually, this is starting to make sense. I am starting to believe that this algorithm is making the right decision. They can go click back up and allow and show that information to the system. So on the next slide, what we show is the actual human in the loop part of this system, which is, hey, fraud analyst, do you accept this recommendation or do you deny it? And if you do, here are some, you can tell us reasons why that was, why you're rejecting the recommendation of the algorithm. That information is the information that's fed back into that hybrid graph machine learning model to make sure that it adapts as fraudsters change their behavior in the real world. So to summarize, let me go over the 4 pieces here that support this technology. There's monitoring, that is making sure you know what's happening in real time with your system and understanding where conditions are changing, boots on the ground, like i.e. as fraudsters change their behavior. There is this operational setting where you have to be able to, you have tools to automatically deploy new analytics algorithms as those operations and those fraudster behaviors change. There is the active learning component, which is the thing we just looked at, where we ingest the information from feedback of the users into the system. And finally, there is the interpretability set of metrics, which showcase the sort of decision-making rationale. Why did the algorithm make the decisions it was making? And if you check out, if you're interested in this stuff, go check out our data products page on the website, because there's lots more information. With that, I will turn it over to Scott.
Right. Well, thanks, Graham. Well, what we just heard was TigerGraph on the back end is extremely powerful. The other sort of takeaway that Graham mentioned that is not sometimes obvious is running the complexity of those algorithms, either running it in more of a batch or an alert mode, which most of our customers are doing, starts to bring rise to the layperson. There's many other humans that are involved in the loop. One of the things that we start to see then is inside of our customers, there's multiple business either units or use cases that are related. And what we see then is anti-money laundering, right? Fraud, internal fraud, external fraud, credit card, check wire fraud, ID theft, et cetera. What you start to see then is the use cases are many, and those are not all of them. What you then start to see then is they are approached in a very similar way. We need humans who may not know any of the complexity that Graham just shared with us. They may not know how to do geospatial and Y clustering and those kinds of things. They've been either in law enforcement or in this investigation, either a short time or a long time. They need to connect the dots. And as we've all seen in the movies where you have the red lines and those kinds of things, they need to take this to close, but they need the accuracy. They need to lower the false positives. And then more importantly over here, they need to use what Graham shared with us inside of TigerGraph at a highly compliant and in a real-time basis. What does that mean? Well, our executives are constantly over on the left saying we need to increase our revenue while simultaneously decreasing our cost and then mitigate our risk. A lot of these now start to give rise to these use cases, or in some cases, different departments inside of our organization. You see the dotted line and the firm line, right? What happens there is these teams, whether you're machine learning or you're an investigation or compliance, they may not share all of that information with each other, right? They need to know that. They need to touch the subgraph, as Graham mentioned, to be able to see their slice of the pie without sort of perturbing the other sides. In some cases, these cases will actually expand. So I may have a cyber case linked to an investigation on a credit card that may be part of an AML use case, right? And the point of this now is we have to interconnect in such a way where it's secure. Now, our investigators are constantly trying to do more with less. They're getting tens of thousands of these a day. They have to parse them. They have to identify what the accuracy is. The other thing is we also know that when starting with a TigerGraph platform, the slate was not clear when you got there. So bolting it on, being able to do it in a timely manner, in many cases, 12 weeks or so, being able to show how this kind of technology boosts what is already there. In Graham's diagram, you saw that Actimize or Oracle investigation or case management, we now want to bump that up with speed and then use the power of the graph to do this continuous improvement. And those are all very lofty goals. But back to Graham's point, right, which is if you're using machine learning today, congratulations. A lot of folks are doing it, and some are doing it better than others. And it's hard. It's not an easy thing to take a lot of those concepts and inject it into an older SQL environment. But what we are empirically seeing then with our customers is that by using graph and machine learning, we can see at least a 6% increase. The next part of this is to put it in the hands of a human multiple humans that actually can make heads or tails out of this, take that power, harness it, and then do it in a very simplistic way that is very powerful. And that's where we see this overall increase. And these are real numbers, right? So customers that we've been working with now are increasing their accuracy, their process throughput, et cetera, by using TigerGraph, and more importantly, the TigerGraph fraud toolkit, to be able to bring the whole solution together. Now, the great thing about that toolkit is it's an SDK, so customers can extend it, they can modify it, et cetera. And that's really sort of where we're going here, is how do we use these toolkits? Now, why do we have these? Well, at the very bottom, we see basically what we do at the algorithm level, at the platform level. TigerGraph Studio is a great product, very fabulous at that. But there are many other people in this process. So whether you're building alert rules or doing investigations or doing detailed case management, et cetera, all the way up to dashboards, that's really what this next part of the journey is about, right? The human who's working in conjunction with IT and our machine learning staff need to know what those are. Use the power of the graph, as we see in this picture over on the right, find similar patterns, but I don't need to know all of the details. If I'm standing on the shoulders of my team like Graham, they can write those complex algorithms for Louvain or Dijkstra or connectedness and lots of other ones. But what I need to see then is, what does it mean to go file a SAR, or how do I go do this to investigate? Or quite frankly, was there nothing there? And I can tell the system, the next time I see this, I don't want to see it again. And that's what we see in this case flow over here. Find it, solve it, document it, prevent it. And then let's learn and let's teach the system to be stronger going forward. Now, we mentioned those different pods, the ability by these teams, right, to have security and be able to connect and then separate the data. That is a very, very important element. The other thing then is, how do these individual investigators work with this capability and then allow the segmentation of the data or combination of the data? That's where we're going. Now, what I'd like to do is give you a quick walkthrough. Now, in this demo, we see those different users, right? We see our executives. In this case, these are fraud alerts. And for those of you that are familiar with different styles of fraud, or SAR or AML or investigation, what you start to see then is we're finding that alert that Graham said. We may be looking for connected data. We may have degrees of connection. We may have strength of connection, but we've simplified that in what looks like a very simplistic dashboard. We can change those on a daily or weekly style. Now, these could be in your Tableau database, et cetera. This is sort of more two-dimensional data. Where we'd like to go now is, let's talk about how that graph or the connected data that Graham talked about is so powerful. The first step on our journey is what we refer to as an alert. An alert could be those three things in that one box. What we saw was, I may want to come in, I may want to look at this over here, and what I can see then is I have this very specific style. I may want to take a Boolean or simplistic. In this case, I've said that if a transaction comes in from a high-risk country, right, or I could select my own geography, right, and it comes in, I can say, okay, let's say it's just Mexico. If it comes in from Mexico, or I want to now look at a TigerGraph algorithm, that one that we mentioned that we continue to talk about is Louvain. Or I could do page rank or weighted rank, right? What I'm now doing is I'm building in the business side, I'm building and using a more complex weighted algorithm of risk or paths or similarity or closeness or any of these other ones that Graham mentioned. And now what I can do is I've injected this very sophisticated search in addition. Now I can do other things like amounts or volume of transactions, et cetera. But the point of this now is I can build as many of these criteria as I like, so that these are now alerting the human being. Now, when I'm done, that can take that geography, or my TigerGraph in combination with my algorithm and these other sort of predicates, as we call them, and I can group them, or I can build a review for alert or workflow, right? Or escalation teams or other kinds of high priorities, right? The point on this now is, now my layperson in their dashboard over here has something that's fired or been triggered. And the beauty of this now is I can dig in and I can actually come in and say, well, here are all of those different statuses. I see some KPIs, et cetera. But now what I'd like to do is I'd like to go look at what did the graph find, as Graham mentioned. And what I see now is there are 4 cards, right, that were connected. There were 4 five devices where maybe a MAC ID, et cetera. Now, all of these data elements or attributes, as we saw from Graham's, is defined by your data model inside of TigerGraph. So if you're doing other kinds of fraud, this is easy to add, and then the system will automatically read those data connections. And then as the data comes in, now what I can see in this particular alert is I can have the system automatically generate that connectivity for me. And now what I can do is I can just simply double click on it. What I've done now is I've elevated what normally takes a week and is sometimes inaccurate. When we saw that 11% accuracy boost, that's on the same data. So analysts and investigators now have this increased accuracy, and I have the ability to sort of do the drag and drop functionality here. Now, there's two ways to do that. In this case, the system found it for me, as Graham mentioned. The second way to do that is to perhaps come in and go look for other kinds of things, right? So I may want to come in, I may want to look at investigations that already exist. I may want to drag those over and start to interrogate those. Now, in the graph database, we can do other things. We can show these connections, as we all know, and we can start to see details of that information on the pane on the right. The other thing that I can start to do is move this into a more viewable layout. Again, I want to see these connections. I see that Parker down here has done many things, but now what I'd like to do is inject the series of risk, right, which is very important. That's an algorithm that ran in TigerGraph. And now I can also see time. So as I move through time, I'm able to see and recreate what it is that Parker was doing and why was this so bad, right? And when I do this now, I can save this. I can attach this to a case. I can investigate even more. In this case, I can double click on a company, and then I can actually go add other individuals perhaps to see if they're connected with this. And what I'm allowed to do now is, in a very simplistic way, interact with very complex data, interact with very complex algorithms, and be assured that this complexity and accuracy has increased. The other thing that I can do is I can do things like auto grouping. I can now have the system in TigerGraph come in and say, well, all of these different transactions based on that alert with a TigerGraph connectedness algorithm has shown me that all of these different elements here have been aggregated, and they perhaps are attacking us in a very rapid fire manner, and I want to add that to a case. And the point here now is to use this toolkit, allow it to be adapted to go do those kinds of things, because in the last leg that we have here, right, we want to go look at our case. And the way we do a case is we can go look at all of those connections, those alerts that were triggered by TigerGraph and those other kinds of connections, the subject information that I just saw, and then how do they all connect together? That's the last leg. And we can then move this into a case or a SAR. I can print forms, etc. And so that's now that moment of how we've moved from using the power of graph, augmenting it perhaps to this next level. Now, when we talk about this data that Graham mentioned, right, how do we use that data up front? These are all important elements that you saw in that dashboard now, where I can recommend to the human to say, look, I found this person on a PEP list, or I have an existing system that perhaps gave me a recommendation, and now TigerGraph has actually moved it up a notch. These screens have been designed, again, for different users. You may have level 1 investigators, you may have level 2 investigators, you may have teams, blue teams and red teams, right? But what you can start to do now is harness this power in a very simplistic way. As Graham mentioned, this idea of recommending, that's really where we're trying to go in that last sort of enlightened tier, where I have the visualization, I have graph, and the power of machine learning is give the user a recommendation. They may not have seen these recommendations before. They may not know sort of good from bad. And that's the difference between a senior analyst and a junior analyst. But now we put them all at the same level. And then that feedback, right? The other element then is geospatial. And many of the times in financial crimes and fraud, we're looking for how things are in different ways. One of those slices is in a geospatial. Should things be happening in this region? Should they not be happening in this other region? Combining those risk scores that Graham showed us how to build over here allows us now to bring it together in, again, a more humanistic way. The other thing then is time. The alternate view of what I showed was more of our node connection. This is more of a simplicity or subway diagram. This shows us sort of what happened when, and then again, through that time series at the bottom, I can start to slice and dice in a very different way. Well, that brings us now towards the end. So If what you saw today was exciting, we hope it was. Here are a couple of other links. And these are not the only toolkits. So we do and use these toolkits in TigerGraph for you, the developer. So these toolkits are designed to be expanded and extended. And then also from a business user perspective, they can be harnessed as they are or augmented by your team or TigerGraphs. So with that, we come to a close.
So before we do that, Scott, there was a question that came in earlier that I thought we could answer live.
Sure.
And that is that entity resolution technique using some vector type scoring in order to feed this to the human readable parts of the flow? And this came in when Graham was presenting.
Sure, I can take that one. So is it using vector scoring? Yes, indeed. The scoring and the confidence of that score are related to the characteristics of the either person or company that it is scoring, or the pairs thereof, rather. And so what you get out is that you have a confidence based on whatever explanatory reasoning the algorithm suggests. So for instance, and is this fed to human readable part of the workflow? Yes. What you would see is a recommendation from that algorithm that says, hey, we think these two companies are the same because look, their addresses are similar and their phone numbers have the same area code. It's just the names that have a couple letters of difference or whatever the case may be.
Okay, great. Thanks, Graham.
It looks like there's a few other questions here as well. The first one here says, it seems to me that the fraud is broader than AML. Could you simply be trying to steal without money laundering? I think hopefully what you saw here is that the approach and the system is designed to catch many different kinds. So many times we find fraud crime rings, other kinds of things that were unintended by looking at transactions for credit cards or transaction or cyber. So the answer is yes. The beauty of that is the system is really designed to catch many things. The use cases may define the style or the recipe, if you will, of those runs that Graham had mentioned. So you may run a community detection on a credit card or a simple style of login to your account for a credit card use case versus running something different for a different style. But basically the approach is the same.
Cool. Another question was, what have you done to combat bias in the code?
Sure, I can take that. So the operational representation of bias depends on what type of setting you're in. So for instance, if you're looking for an anti-money laundering ring, again, it could be something else, as Scott just mentioned. You're looking for a money laundering ring that is, you have trained across the world, the data comes from all over the world. You may find that the behavior of fraud rings that are represented in, I don't know, whatever, Brazil is different than that of the rest of the world. Well, as it turns out, you can monitor those effects based on the inputs from your data, which you already have in-house, and the performance of the system, the outputs of the recommendation. So you kind of rectify against what's recommended against what comes in. And then you can make, based on the differences there, you can actually highlight some of those inconsistencies to the users, whether those are fraud investigators or actual data scientists.
Cool. Thanks, Graham. How about random phone calls, emails, etc. by phishing? And I think the follow-up is, can you identify the fraudsters?
Sure. So I'd be happy to dive into the specifics of that implementation in a call. So our contact info is up there. Feel free to reach out individually. The behaviors that typify those sort of spam calls and emails, that is similar to what we find in sort of financial crime fraud. And so one example of that, for instance, is that the phone calls that are coming in are routed through a particular phone board that has certain characters in the phone digits, for instance. There's a lot of these things. And when we detect that inside of a graph, we can, of course, surface that information to user. And then, if you have the data to connect that back to the individual people enacting those calls, we can indeed identify those fraudsters.
Awesome. Thanks, Graham. Okay, I think that's all the questions. Scott, didn't mean to interrupt. Please continue.
Hey, there was a few other ones that were answered in the process, which says that basically there was one about the fraud algorithms. I would invite everyone to go to the GitHub, as Graham mentioned, there's roughly 32, if not more, and you'll find there's a whole variety of different kinds of algorithms that are pre-built there. Those are easy to drop in and use inside of TigerGraph, and in fact, there is the web version of TigerGraph where you can go do it for yourself, and highly recommend that. The other question was around the workflow or business rules on top of this. That's actually what the toolkit allows you to do, is to allow you to customize to your business process. And several of our customers do that today. That was just a little excerpt of what I had showed in the demo. And again, we'd love to sort of show you how to do that. And those were some of the answered ones. Back to you.
Okay, well, do we want to wrap up?
Sounds good. Any other questions? Anyone else? Last chance. Okay, sounds good. Thanks, guys.
Okay, thanks for joining us today. Hope you found this to be interesting and informative. And feel free to reach out to Graham or Scott if you have suggestions or questions. And with that, we'll end the webinar. Again, thanks for attending. We know you're busy, and hopefully this was useful. Bye, everyone.